Hi everyone. Today I'm here to present my FYP project study results after the first semester of screening of stroke patients in Chinese medicine by machine learning. Our project aims at using the bigger datasets and the machine learning rules to simulate the traditional Chinese medicine diagnosis results. In this semester, we mainly do two things. First one is we handle the raw data we collected from the previous work, and from the hospital we got some data too, and we sort out some symptoms which is suitable for the following analysis, and we also clean it in our own way. The second one is we change the model of association rules using a relative small amount of data, which we have already handled it, and it's quite clean and suitable for the model training. And then the association rule model will be more suitable for the following coming study for the larger data set. Since it's a two people's project, me and my partner cooperate very efficiently, and most of the time we divided our work equally. But we did have our different focus. Like in the earlier periods, I focused more on the dealing with the raw data, like using 结巴 or other methods, and try different method, and she's more focused on finding different machine learning rules. Like finally we decided to use the association rule, and in the former periods she's more focused on the programming of the association rule, and I'm more focused on running after the data. We run out some results, like some symptom sets, like some patterns. I'm more focused on evaluating them and applying them, comparing them with the traditional Chinese medicine diagnosis. When we handle the raw data, the main idea and the process is first to change the data into the sentence in digital form in Excel, and because most of them are a full sentence, so we have to cut it into the symptoms, and we need to collect the useful information in each sentence, in which we first decided to use the 结巴分词. But during the process, we found that because traditional Chinese medicine have a lot of its own words that is not very usually seen in our daily life, so the 结巴分词 cannot cut the phrases very well, and sometimes it chops the phrases into two small pieces, like the symptom 四肢不遂, which is very useful in the following analysis, but it would just cut it into two meaningless words, 四肢 and 不遂. So the next step, we decided to build our own dictionary. Like I collect some traditional Chinese medicine words, a lot of symptoms from online, and make a list, and then put it into the dictionary of 结巴. But maybe our list is not very complete, like we cannot find very completed list online, so we have to but we think that instead of building a dictionary that needs a lot of time, consume a lot of time and energy, we think that in this period of study, we are training the model and we are handling relatively small amounts of data. Maybe we can do it manually. That would be more practical and less time consuming. So we decided to handle the raw data one by one, and we cut it into useful phrases. And in this process, we also follow some of is that we clean up those irrelative sentences, words. And the second one is that we classify those symptoms with exactly the same meaning and different expression. Like in different ancient books or different doctors will describe the same symptom in different words, in their own words. So we treat them as the same symptom. After dealing with the raw data, we apply the model we built according to association rule to analyze that whether the symptoms will come appear together rationally in different scenarios. So the association rule have two very important parameters called support and confidence. With higher support and confidence, that means these two or three symptoms, in our case, is true. So will appear with higher possibilities. So we use a priori algorithm specifically in our study. A priori algorithm is a relatively simple algorithm, so that we use it because it has simpler structure, but it's time consuming because it just go through the item set one by one each time. Is going with higher order of item sets. For example, it goes through the item set with two candidates and find those frequent item sets, and then it uses the item set with two candidates to find the ones with three candidates. So that's the mainly mechanism of it. After applying the association rule to the data, so we come up with the top 10 symptom sets that with the highest possibility to appear together. And we found out that the several symptoms appear several times repeatedly, and also in the when we do the 解八, we also sort out the top 10 single symptoms in all the raw data. So we find out they also have showed up several times in the top 10 symptoms. So we further summarize the symptom into three patterns. We further summarize those symptoms into three patterns, which each pattern contains 4 or 5 symptoms. So we first suppose that maybe each symptom set, the pattern is corresponding to 火热、气虚 or 阴虚 in traditional Chinese medicine, because that is how they divided the stroke symptoms in traditional Chinese medicine. But we find out that they are not very correspondingly matched. So we think that is what our future work maybe can consider, is that how can our model more match to the traditional Chinese medicine's professional diagnosis. That is one of our limitation when we are doing this case. So that's all for the presentation. Thank you.